Sir Isaac Newton established a third law of motion describing every force occurs as one member of an action-reaction pair, with the SI unit of force being N newtons. The two members of this pair act on each other and point the force in opposite directions while also being equal in magnitude. In other words, anytime one object pushes and pulls on another object, that object will return the same equal force onto its counterpart. Furthermore, Newton's third law is commonly referred to as the action-reaction law, and the equation representing it is F of A over B equals negative F of B over A, basically showing how two different vectors of forces with the same magnitude and opposite direction are equal to each other. The negative sign only displays that the vector is going in the opposite direction. Our project is a prime example showcasing two carts pulling and pushing one another, highlighting the fundamentals of the third law. The example consists of the use of two carts and two Newton scales, accompanied by motion sensors that are captured on capstone. This program displays one of the vectors of forces onto the negative side. However, this doesn't mean that it is going in the negative direction, because in reality both vectors of forces are equal in magnitude and going in the opposite directions. It is displayed this way to allow students to interpret the vectors of forces and magnitude easier on the graph. The example we conducted is set up in a way that when the hook is being pulled, the force is shown in the positive direction, and when pushed, it is displayed in the opposite direction. In the diagram shown, it is a replica of our experiment, and the only action-reaction pair that is present is the tension of A equaling to negative tension of B, which is exerted by the rubber band itself. Okay. The Newton scale shown here is another component used to display the amount of force being used. The experiment began by pulling the Newton scales at the same time while gradually increasing in force up until 14 seconds on the graph, peaking at 8.4 newtons, as seen on capstone. After hitting peak force, the force was gradually decreased close to zero, as both moved in alignment with one another, displaying equal force and opposite direction. We continued to test the experiment by repeatedly increasing and decreasing force on Newton's scale, which resulted in increased and relieved tension that is displayed on the graph as well. In conclusion, Newton's third law is basically stating that every force occurs as an action and reaction pair. Our experiment shows this exactly by displaying how two vectors of forces that are equal in magnitude but are going in opposite directions are equal to one another. Furthermore, all this was done while avoiding the spread of COVID-19.